Welcome to my presentation. My name is Rusty Belcher. I just finished my Autodesk Certified Instructor training program this week, and I really did enjoy the training. It was fantastic. As part of that training, I had to develop two 30-minute presentations for the class. And I figured since I worked on these presentations, I'd record them and put them on my YouTube page. If you are an Autodesk instructor, and you're getting ready to attend your ACI, I need you to understand that this is just a video recording of my presentation. The Autodesk Certified Instructor program is really about in-person training and the delivering of training to a live class. So please keep that in mind if you're looking at this presentation. Hello, my name is Rusty Belcher. The software that we're going to be using in today's presentation is Autodesk Inventor. The module that I chose is really the assembly/visualization module. In today's presentation, we are going to be using or creating exploded views in Autodesk Inventor. And exploded views are a byproduct of the assemblies. But exploded views also fit into that visualization category. This is fundamental level training. Students actually encounter these exercises on the 4th day of the Inventor Basics class. And at this point, the students are familiar with parts, part modeling, assemblies, and a little bit of drawings. As a matter of fact, the previous lesson prior to this lesson might have been one of their first Inventor drawing exercises. Well, in today's presentation, our goal is to create exploded presentations for assembly instructions and bills of material. We really have two major objectives that we're going to achieve during this presentation. We're going to use individual tweaks to position the components of a cable modem into an exploded view. Our second objective is to produce an exploded drawing view of the cable modem with a bill of material and balloons. I think we've all heard this expression that a picture is worth 1,000 words. Well, I have a question for you. If a picture is worth 1,000 words, then what is a video worth? I'm going to go ahead and open up a video for you here. This is a video of a project we did a couple of years ago for a customer. And this is actually a very small LED flashlight that attaches to the ball cap or to the brim on your ball cap. It's simple plastic construction. There's a couple of O-rings and a couple of snap fits that hold this thing together. You can see me inserting the batteries, and you can see me spinning the battery cover in place. And you know what? I think I could actually stop talking here and let the video do all the talking for me. I hope you see this video is clearly showing you how to construct the clip and how to attach the clip to the bill light. And if I let this thing play in reverse, it'll actually show you how to take the bill light apart, or how to remove the clip, how to disassemble it, and then how to remove the batteries from the casing. And this is really an example of one of the primary points we're going to be talking about in today's presentation, is assembly instructions. You know, assembly instructions are not what they used to be. I think all of us, when we need to know how to do something, we all now want to go to the internet and find out how to do it. And let me ask you guys a question in the class here. What's the first place you go to on the internet to find out how to do something? Well, for me, it's YouTube. I go to YouTube first. I think YouTube's fantastic. If I want to know how to do anything, maybe use any piece of software, YouTube is literally one of the first places I check online. And for some of us who have been creating assembly instructions for a long time, we are so used to these assembly instructions being something that's included on the drawing in a 2D form. And that's not the case anymore. Assembly instructions are more often 3D now and available online in a video format. A lot of you have children, and you've bought your kids that big elaborate box of Legos, and I think you've all had that experience where you open that box of Legos, you see those thousands of bricks, and the first thing you go to look for is the assembly instructions. You have to have those assembly instructions. If you don't, that pile of bricks is just a pile of plastic bricks. Without the assembly instructions, there's nothing you can do but just use your imagination and build something from scratch. Have any of you ever bought a hutch at the furniture store? And you see that hutch, you pick it out, that big gigantic piece of furniture, and then when you go to put it in the car, they give you a box. It's like that IKEA furniture that folds down to a 2-foot by 3-foot box, about 3 inches deep, and inside the box is nothing but wood and fasteners, and you know you have a big job ahead of you building this piece of furniture. Can you imagine getting that thing home and not having the instructions inside of it? Without the instructions, that's just a box of useless lumber. Instructions are a critical part of many of the designs that we produce. I've often said it that if you make an assembly with more than 10 parts, you have to have some view on the drawing that shows your customer how to build the component. So this brings us to our first objective today, and that is to use individual tweaks to position the components of a cable modem in an exploded view. We have a simple little cable modem. We have a simple plastic case with a top part and a bottom part. Inside the case is a simple PCB board. There's a connector to the left and a wire to the right. And we're going to show you the process of generating the exploded view in Autodesk Inventor. In Inventor, we're going to be utilizing the presentation environment. We use the presentation environment to create our exploded views. And there's really just a couple of commands you're going to be using in today's exercise. You're going to be using the tweak components command. It's tweak, not twerk. Don't get that confused. And you're also going to be using the animate command. The tweak command is fairly simple to use. It's really a 3-step command. The first step is going to be to establish a direction. You can pick any face or edge to establish a direction. The second step is to select a component. You can select any component in the design. And then you can adjust the trail. Now you don't have to adjust the trail. Only every once in a while do you have to adjust the trail. And then you'll finally drag it to the desired position. So now it's time for the demo. Now I really need you to focus up front and watch what I'm going to do during the demonstration. You guys, if you're typing on the computer, if your hands are on your mouse, you're not really focused on what I'm doing up here, and I really need you to focus up here during the demo time. I'm going to be giving you the demo on the same exact activity that you're going to do in the exercise later. So I'm going to jump into Inventor, and I'm going to go to File, Open. Now the exercise that you're going to use today is this ACI socket presentation file, an IPN. Here's the icon for an IPN. Presentation files are the environment that we use to generate exploded views in Inventor. So you're simply going to open up that file. I've already loaded the assembly in place for you, and you're going to basically start the tweak command. The tweak components command is right here. The second command on the presentation panel. Now, if you've never used Inventor before, these dialog boxes, I think you'll be very impressed. They're very, very nice and very easy to use. Most of the time, we don't really interact with the dialogs at first. The dialogs are primed, and they're ready to deliver the functionality immediately. So if I look at this dialog, I see the direction, I see the components, and I see the trail origin. But really it's asking me to pick a direction already. So to define a direction, you can select any face or edge. Now the face and edge do not have to be on the part that's going to move. So I'm going to drop the little direction off at the top part that we want to move, and then you need to select the component. I'll simply come in and select the component there, and I've already answered the first 2 questions in the dialog. Now we need to move the component. Now there's a pitfall that happens a lot with new users in the exploded presentation environment. Everybody thinks that you have to drag on the part to move it. Well, when you go to drag on the part, you might inadvertently select another component. You don't want to do that. So to avoid that, you're going to take the cursor, put it out in space a little bit, and left click and drag upwards until you think the part is in position. I like to say you're going to drag it up to where you think it looks good. Once the part's in place, you can select close and finish the command. Now it's just a matter of repeating the command until you've positioned all the parts. I'm going to start the tweak component command again, and this time I'm going to move the little connector part. So I'm going to drop off my direction, and I want you to focus on the direction this time. The direction is actually a little UCS triad, a little XYZ indicator. And I want you to notice how the Z-axis is actually colored. It's actually highlighted as blue. It's the active direction. And that corresponds to the dialog box up here where we're moving on the Z. And you can make changes in the dialog if necessary right in the middle of the tweak. So for this example, I've picked my direction. I'll select the component. That's our second step. And then I'll simply left click and drag upwards. Now for this part, I want to drag it up and then I want to drag it over to the left. So in the dialog, I'm going to come over and select my X direction. Notice how the X axis lights up, and I can drag it over to the left. Once it's in position, I close the dialog. The next part we're going to move is the wire. Now I'm going to just pick the top of this little PCB board for my direction. Then I'm going to select the component, which is the wire. Now I want you to focus on the trails for a minute. The trails actually point to the center of gravity of the part. That's how the trails know where to point. It's to the part's CG. Well, this wire is a bent part. It actually bends around to the right. And that puts the CG out here in space, and I don't want that. So this is an example of when you'd go to the dialog, actually click the Trail Origin button, and then you can establish the trail to go anywhere you want. I'm simply going to pick a point on this face, and then I'm going to zoom back out, and the command is basically the same as it's always been. You're simply going to left click and drag upwards. I'm going to change my to the X direction, drag over to the right, and then I'll select close to finish the command. It's a very straightforward workflow. I'm going to do our last tweak. We'll pick our direction. The component we want for this is the lowercase part, and we'll simply drag downwards again to where we think the part looks good. I'll click close, and you have created your exploded view. Now, if you want to generate an animation, that's where the animation tool comes in right here. You can click the animate button. I'll just position this over here so you can see what it does. And just like on your DVD player, or maybe you still have an old VCR, you can click the play button and you can actually view the animation. It's already set up for you. Basically, it will go together in the reverse order of how you took it apart. You can pause it at any time and play it in reverse and show the instructions for taking the thing apart. If you look in the animation dialog, you'll find this little red button, and I'd ask everybody, what do you guys think the red button does? Well, just like on your old VCR or your old tape recorder, the red button is the record button. And if you wanted to generate a video of this presentation, all you got to do is click that button, and you're on your way to creating an AVI file or a WMV file. So that's really the exercise that you're going to do. So let me hop back over to PowerPoint. What I want you guys to do now, I want you to open up Inventor, and I want you to open up the ACI socket presentation IPN file. I want you to use the instructions that are up on the screen to build your exploded view. You're going to use the tweak command. You're going to use the tweak command to place the components in the exploded view just as I showed you during the demo. After you've done the tweak, if you want to make adjustments, you can just use the trails. You can drag the trails and reposition the parts if you want to try that. And then when you get finished, go ahead and animate it. Go ahead and use the animate tool and animate your design. If you have any questions during the exercise, please let me know. Raise your hand. I'll come back. I'll be walking around. If you have any questions, if you need some help, please let me know. And you guys, we want to finish this exercise in about 4 minutes. So again, if you have any questions, please let me know. Well, okay, as you finished your exercise, go ahead and let's look up here. We're gonna run through another little lecture here for the next step in our process. Well, if you remember, I started this whole presentation with a question. A picture is worth 1,000 words, then what does that mean for a video? Well, I have another question for you. Can a picture really be worth 1,000 words? Well, remember that scenario about going to the store and buying that nice piece of furniture and you get it home and you realize the assembly instructions aren't included. Well, if you had to talk somebody through the assembly of a process, you could easily exceed 1,000 words. If you had to call the help support and complain that the instructions weren't in the case with the furniture, I think you would exceed 1,000 words there as well. These assembly instructions are so important, and when it comes to assembly instructions, absolutely a picture is worth 1,000 words, if not more. We use exploded views a lot in my design experience. Many customers use it not just for assembly instructions. Exploded views are fantastic for assembly instructions. That is really one of their primary uses. But we also use them for itemization. We also link that itemization to the metadata via the bill of materials. A lot of times you go to the assembly instructions to find an item number, and then you go to the bill of material or to the parts list to find out the necessary information about that part. For instance, maybe the dimensions are recorded for this piece of wood. Maybe the material is included, or the thickness of the material. That information is not necessarily on the drawing view, but via the itemization bubble, you'll find it in the parts list. So these exploded views become kind of a central hub view in our drawing. Everybody goes to that view to find out the link to the next destination in the drawing that they need to get the information they're looking for. Exploded views are nothing new. People have been doing exploded views for years. But now when it comes to exploded views, classically there are some drawbacks to the process. Exploded views have always been understood to be a very time-consuming process. More and more in today's world, this idea of hand-drawing exploded views is just a dying art form. I've actually seen exploded views, and when I encounter them like this, like you see up here on the screen, they're usually under glass in a frame, in the boss's office or in the conference room at a design firm, because we literally view these as works of art now. In the past, an exploded view, specifically for people using two-dimensional CAD applications like AutoCAD, exploded views have been something that is just unbelievably difficult to do. If not, they're considered impossible to do in a classic 2D application like AutoCAD. And the major drawback has always been that it's not associative to the design. If the part changes, or if something changes in the design, these complex views do not update automatically. So for many years, these things were left off of drawings just because they were so difficult. But now, they can easily be included in our design. This brings us to our second objective. We want to produce an exploded drawing view of the cable modem with the bill of material and balloons. Now, in this portion of our exercise, we're going to be focusing on the Inventor drawing environment. And I want everybody to feel comfortable that, we are going to be producing a DWG file. We're just using Inventor to do it. We are going to be utilizing the base view tool on the Drawing tab, and we're going to be utilizing the Parts List and the Balloon tool on the Annotation tab. So again, it's demo time. I really need you guys to focus up front with me. Get your hands off your mice, no keyboards at this point. I want to really focus on what you're going to be doing during your activity. So I'm going to walk through it for you in Inventor. So back inside of Inventor, it is possible for you to use the assembly file from the previous exercise. If you got through that and you just want to continue on using that exercise, you absolutely can. I also have a separate file for you to use if you want to use it. So what you're going to do is start a new drawing. Now you can simply start a new drawing by selecting the drawing node here, or you can go to the File New area and select the drawing file, and notice it is a DWG file. When your DWG is open, you want to go ahead and start the Base View command, the very first button on the Place View panel. If you navigate out and select the ACI Socket Presentation Complete file, that's the one you want to use. That's the completed version that I'm supplying for you. You'll click Open and you'll notice it comes in on your cursor. Now the orientation that I'm going to use for this example is ISO top right. So I'll set my orientation, and to create the view you simply left click and drop off the view. Inventor always wants to go to this orthographic projection. In this case that doesn't work, so I'm just going to right click and select OK. And there is the view on the sheet ready to go. Now you can position your view simply by dragging this little red halo around, so you can position it anywhere on the sheet. Now we want to generate our parts list. I'm going to go to the Annotate tab, and I'm going to come over here to Parts List. You'll click the Parts List command and then simply select the view. Now if you had the view selected earlier, that's great, it'll automatically select it. We'll click OK and we'll drop off the chart off to the side, and you can see all the components that make up the assembly, their quantity, and their part number. Now we want to put our item numbers on the part with the balloon command. I'm going to start the balloon command. To use the balloon command, I think it's really just simple and straightforward. It's just like any leader command you can use in any other CAD application. You're going to select a part, and wherever you click the part, that's where the arrowhead is going to drop off. You then pick possibly the landing of the balloon, or if I just hit enter, that becomes the destination of the balloon. So it's simply just repeating that process. You drop off the arrowhead by clicking the part. You can lock in the balloon. It will lock in at a particular angle, and just hit the enter button to drop the balloon off. So there you can see how fast and efficient it is to create an exploded view on a drawing from a presentation file. And included on top of that, we have our parts list from the bill of material and the item numbers. And note that the item numbers are perfectly going to match the items in the parts list. So that is your goal for the second exercise. So for this exercise, it's now your turn. I want you guys to grab that mouse. I want you to, in Inventor, I want you to start a new standard DWG. That's really going to be your first step. Once you start the base view command, then you're going to browse out and you're going to use this ACI Socket Presentation Complete IPN file. Just a couple of things to help you out up on the screen. Remember, I used that ISO top right orientation. And I used the parts list and the balloon command from the Annotation tab. So just like before, I want you guys to work through this exercise. Again, if you have any questions, slip up your hand, let me know. I'll be walking around checking out how things are going. All right, fantastic. It's time for us to finish up that exercise. I do want to take just a few minutes and review what we've covered in our class. I think you guys, I'm amazed. I saw you guys create exploded views. Some of you are brand new to Inventor, and you absolutely went through that exercise, I think, with no problem. So you've seen that you can create exploded views for presentation and drawings. You've seen the workflow, and it's a fairly simple workflow. You know it's possible now. So I've got a question for you. How can you now utilize this workflow at your office? Now that you've seen really how easy it is, how can you put this into practice at your office? And maybe more importantly, I got another question for you. Where do your customers go to find your assembly instructions? Are they going to your drawings in classic 2D form? Or maybe you're thinking now that, hey, we can set up a website or a YouTube page and we can put our assembly instructions out there. Take advantage of YouTube and take advantage of these three-dimensional assembly instructions. All right, it's time for our next lesson. In our next lesson, we're actually going to be looking at the process for producing the videos that you saw earlier. Thank you.